Pressure on what the steps are. What do we do first? Given, then find, then the table of all the known and unknown forces so that we can determine what's unknown. Number of unknowns tell us what? Number of equations we need, which tells us how many free body diagrams we need. Then what do? Draw the free body diagram, or free body diagrams, right? So we're all the way down here. Draw the free body diagrams. Find the x, y, and z component of the forces, and then use the equilibrium equations to solve for the unknowns. Why do we do this step? Why do we find the components before we start plugging them into the equations? So we can do a check. Right? So here's the problem. Let's take a look at it. The bent bar shown in the figure is supported with two brackets that exert only force reactions on the bar. So that's pretty important. So at two brackets that exert only force reactions at the bar, on the bar rather. So A and B, look back in your notes at all the different types of supports and figure out what kind of support that is if it only resists force reactions. Okay, so what do A and B look like? They look like one of three. Keep the workshop, turn in Evan. So A and B look like either what? A journal bearing, or a thrust bearing, or the ball bearing. So which one did you automatically throw out? The thrust bearing, right? Because I don't see that there's two things preventing it from moving on the sides, right? Because the thrust bearing, the thrust bearing has those two collars on there that prevent it from moving this way. So we're down to either the journal bearing or the ball bearing. Which one is it? Why? Because the ball bearing allows some rotation, right? So the only thing that it's resisting is the forces. So since this picture is my scrap.
Can you say that one more time, maybe in different words? I'm still not quite sure.
Okay, so you agree that this is one of three. It's either the journal bearing, the thrust bearing, or the ball.
How do you know it's the ball instead of the...
Because it says it only has force reactions on it, take a look at the ball bearing and the journal bearing, and you'll see that the journal bearing locks it in so it can't rotate. But the ball bearing is a thrust bearing, a journal bearing with a line of balls, and it allows it to rotate like this, slightly.
And that
You have to go back to
resists the force.
so that it only resists the force. So let's go around. Radian, let's start with you. So which forces are on B and A? Notice where our axes are. There's X, Y, and Z. Remember, on a 3D problem, always find out where our axes are. So what can it resist? It's resisting force reactions. Is it X, Y, or Z? Or let's do the opposite. Which way can it move? X, Y, or Z? Z, because we're looking at the connection between the bar and this collar here. The bar can slide up and down the collar. So which force reactions does it have? X and Y. So should we call it BX, BY, AY, oops, AX, BX. Does everybody agree with that? Let's see what it says. NC of the bar rests against the smooth horizontal and vertical surface. So Lucas, what is that telling us? Right. One or two of them. So let's read it again. NC of the bar rests against the smooth horizontal and the smooth vertical. Two of them. So how should I draw them?
So one going up towards the bar.
Right? So let's call that CZ.
And then
And
going towards you out of the page.
The X or Y?
X,
X.
CX.
Did I draw them in the right directions? Eric?
Yeah.
Yeah, because I'm looking at the bar, right? I'm analyzing the bar, and the ground and the wall are pushing onto it. They're normal forces, right? If in the end, Enrique, I got a negative value for this or a negative value for this, what would it tell me?
You did something wrong.
Does everybody see that? So I asked him, if I get a negative value for this or a negative value for that, what do you mean when I say I did something wrong?
Because you know what direction is it the normals are in.
Right, so the normals have to be this, so I should get positives. If I get a negative for those, it must mean I did some math wrong. Does everybody get that? How about for AX and AY? Carolyn, if I get a negative for AX and AY, what does it tell me?
It means that the force is directed opposite the.
They're going the other way. And we don't know whether AX or AY are going in the direction we drew or the opposite. We don't know. What are the three forces that we always know the direction of, Uriah?
Normal
Normal, it goes towards the body.
tension
Tension goes
away
from the body, and
compression.
weight
Oh wait,
goes down.
I guess compression's like a normal.
Compression is a normal. Right, so those are the three we know the direction of. So if we get a negative for tension, a negative for weight, or a negative for normal, what do we know?
Something wrong.
We made a math mistake, because it can't be. So if you're running out of time on an exam, and you get a negative for the tension, and you don't have time to go back, you just write me a little note. I know I made a math mistake because tension can't be negative. I drew it in the correct direction. Does that make sense? Just let me know that you know. Okay, so let's do given. So what do we want to do on the given? I'm just going to say sketch. Aaron, is that okay with you, since I wound up drawing a lot of the stuff?
Yeah.
The idea that it's smooth and it's horizontal and vertical.
Yeah.
Okay? Okay, how about find? What should I put for find, Aaron?
Show the reactions as words. AX, AY, BX, BY, and CX, BY.
AX, AY, BX, BY, and what are C's?
CZ and CX, I'm sorry.
Right. Okay, so let's draw our table. Force, moment, magnitude, direction. So we have AX, AY, BX, BY, CX, CZ, and what else do we have? Jabin, what else is here? So I wrote down so far all the reactions at the supports.
Well, the tails coming off the end of the bar there, all the
Right, so there are all these forces being applied to it, right? So there's a 200 Newton, there's a 300 Newton, and a 400 Newton. So, no, yes, yes, yes. Directions, yes. So how many unknowns do I have, David?
6.
6 unknowns, so how many equations do I need?
6.
6 equations, how many bodies? It's a 3D body. 1 3D body. 1 free body diagram. And Jabin, what do you want to draw a free body diagram of?
Here's the bar.
The bar. There's only one thing there. Is everybody comfortable now with realizing in statics we now draw free body diagrams of real things? We're not just drawing a point. We're not picking point A and drawing a free body diagram of point A. We're drawing a free body diagram of the physical thing. Everybody has that, right? Okay. Okay, so now